Okay, so let's just jump right in. A brand new and frankly pretty mind bending scientific hypothesis just dropped today, September 1st, 2025. What it suggests is a hidden layer of communication, a conversation happening between us, the world around us, and even our gadgets. It's called the fifth sign, and if it's right, it could change how we see, well, pretty much everything.
So let's get right to the heart of it with a question that sounds like it's straight out of science fiction. Can your gaze actually talk to your phone? And no, I'm not talking about eye tracking software. I mean, can your focused attention create a subtle, invisible field that your device can actually read? It sounds completely wild, but that's the central question these scientists are setting out to answer.
And this is the core concept right here, the fifth sign. Yeah, they mean it just like that, a new vital sign, like your heart rate or blood pressure. The theory is that there's this hidden field level channel connecting three things we would never think to put together: our gaze, the cloud of microbes all around us, and our devices. And the really big idea is that if this channel exists, we could actually learn to engineer it to make us smarter and healthier.
All right, so here's our game plan for unpacking this. First, we're going to explore this invisible conversation. Then we'll look at the actual to-do list for scientists to test this thing. After that, we get to the fun part, what this could mean. We're talking smarter rooms and calmer AI. And we'll end with the most profound part of all, this idea of life as a Mobius loop. Okay, first up, the invisible conversation. This is where the paper starts connecting the dots between some very different scientific fields to build a case for this hidden channel of communication. So let's start by looking at something we do constantly without a second thought, just looking at things. The paper argues that our gaze isn't a passive act at all. It's a biophysical trigger. When you focus on something, you're changing your body's electrical state. And get this, your body is actually emitting ultra-weak photons. Yes, you are literally emitting light that's tied to your brain activity. The theory is that these tiny physical changes could actually influence the quantum state of molecules right around you. Okay, so if our gaze is the signal, what's it traveling through? Thin air? Well, sort of. The paper introduces this concept they call the MIMCAP. You can basically think of it as the cloud of dust, aerosols, and microbes that's always in the air around us. The point is, the space between you and your desk isn't empty. It's a living, persistent medium that could be carrying these signals back and forth.
And the paper puts it in this really beautiful way, calling it a living cloud, a continuously exchanged background that couples people, places, and objects. I mean, just let that sink in for a second. An invisible living network connecting everything and everyone in a single room.
And that brings us to the final piece of the puzzle, our devices. Your phone, your laptop, they're not sterile pieces of glass and metal. They are completely coated in your own unique microbiome. This creates what the paper calls a hybrid surface. It's part biological, part electronic. And that microbial skin on your phone could be the antenna that's picking up the signals traveling through that living cloud. So how would this all work in a chain reaction? Well, the paper lays it out. Step 1, it all starts with your gaze or your touch, which changes your body's physical state. Step 2, a microbial film nearby, say on your phone, picks up those tiny signals. Step 3, your phone's existing sensors detect a change in that film. From there, an AI could use that data to change its own timing, which could ultimately lead to a real, measurable change in your own behavior, like, say, helping you remember something better. Now, of course, a big idea is just, well, an idea until you can actually test it. And this is where the paper gets really serious. It lays out a clear scientist's to-do list, a plan to rigorously test this hypothesis, and, maybe more importantly, to try and prove it wrong. And I love this part because it's just great scientific honesty. They created what they call an evidence ladder. It separates what we already know for a fact, the established stuff, from what's plausible, and then it clearly labels their own new ideas as speculative. This is the stuff that actually needs to be tested. You know, this really gets to the heart of how good science is done. The goal isn't to go out and prove your pet theory is right. The real goal is to try your absolute hardest to prove it's wrong. Because if an idea can survive every single attempt to break it, then maybe, just maybe, you're onto something real. And they're not being vague about it either. They're setting hard numerical goals. For one of the key experiments, they're looking for a light phase shift of at least 10 milliradians. It's a tiny, tiny measurement, but it is a concrete line in the sand. If the data doesn't cross that line, the hypothesis fails. Simple as that. In fact, they've defined their own failure conditions before even starting. They write it right here. Failure to meet these thresholds constrains or rejects the framework. In other words, they're saying, if we run the test and the data isn't there, we'll be the first ones to say the idea is wrong, or at least that we can't detect it yet. Now that's scientific integrity. So let's just imagine for a second that some of these experiments actually work. Why should you care? Why does any of this matter? Well, this next section is all about the real-world applications if this hidden connection turns out to be real.
First, just think about our relationship with AI. Instead of your phone just reacting to your frantic taps and swipes, what if it had a microbial skin that could sense your biological state, your biofield? An AI could learn to give you information when you're most receptive and just stay quiet when you're overwhelmed. The goal isn't more tech, it's calmer, more intuitive tech.
This could also completely change the way we learn. Imagine a study app that could sense your precise state of focus and deliver a key piece of information at the exact micro moment your brain is ready to lock it in. And again, they propose a concrete test for this, a system that can boost memory recall by 10% or more. And the applications could scale way, way up, from our phones to our entire cities. If this living cloud is a real measurable thing, we could start engineering it. We could design buildings and public spaces that actually shape these invisible flows to support public health and maybe even our immune systems. Our environment could become an active partner in our wellness. All right, and that brings us to the final and maybe the most profound implication of this whole hypothesis. Because this isn't just about technology. It's about a fundamentally new way of seeing ourselves and our place in the world. And it all comes down to this powerful metaphor, life as a Mobius loop. You know, that's that strip of paper with a half twist in it, so it only has one continuous surface. There's no real inside or outside. The argument here is that the boundary between you and the world is basically an illusion. It's all one continuous two-way street. This worldview sees the body as a series of nested microbial fractal shells. It starts with the microbiome in your gut, which influences the one on your skin. That then creates a personal plume of microbes you shed into the air around you. That plume becomes part of the room's microbiome, which then becomes part of the city's. It's this beautiful, layered system where the same rules of connection might just apply at every single scale. Which, of course, leaves us with this one final, really powerful question. If this constant, invisible exchange is actually real, if there's no clear boundary where you stop and the world begins, then what exactly are we? It's a thought that goes way beyond the laboratory, and it's what makes this new hypothesis so incredibly compelling.